September 23, 1999. NASA's Mission Control. Dozens of engineers have been waiting for this moment for 10 months. The Mars Climate Orbiter is about to enter orbit around Mars. $125 million. 10 months of travel. Years of preparation. And then, silence. The spacecraft disappears behind Mars. And never comes back. Not because of a technical failure. Not because of a meteorite. Not because of a malfunction. Because someone used the wrong units of measurement. That's it. That's the whole story. Except it isn't. Let's back up. It's 1998. NASA is under pressure. The space agency has just lost the Mars Observer, a billion-dollar probe that vanished in 1993. Congress is asking questions. Budgets are being cut. So NASA Administrator Daniel Goldin comes up with a new philosophy. 3 words. Faster, better, cheaper. Instead of one massive, expensive mission every decade. Smaller probes, more often, lower cost. The Mars Climate Orbiter is one of the first products of this new approach. Smaller, leaner, built partly by an outside contractor, Lockheed Martin in Denver, Colorado. 2 teams, 2 locations, 1 spacecraft. What could go wrong? The Mars Climate Orbiter is an elegant piece of engineering. Its job: orbit Mars, study the climate, map the surface, and act as a communications relay for the next mission, the Mars Polar Lander, already on its way. It launches December 11, 1998. Everything goes smoothly. 10 months of travel through deep space. 4 course corrections along the way, all routine. The navigation team at JPL, the Jet Propulsion Laboratory in Pasadena, tracks the spacecraft daily. They calculate its position. They send commands. They monitor the data coming back. And for 10 months, everything looks fine. Almost everything. Here's where it gets interesting. Throughout the journey, the navigation team notices something slightly off. The spacecraft is drifting. Just a little. Every time they fire the small thrusters to correct the course, the correction is slightly wrong. They log it. They flag it. They run the numbers again. The numbers don't quite add up. One engineer, a young navigation specialist, actually sends an internal memo raising concerns. He thinks the trajectory is wrong. He thinks the spacecraft is going to come in too low. The memo goes up the chain. Nothing happens. Why? The team is overworked. The faster, better, cheaper philosophy means fewer people doing more work. There's no independent review. No one double-checks the double-checkers. The error doesn't get caught. It keeps accumulating. Day after day. Correction after correction. For 10 months. Now here's the single point of failure. Lockheed Martin software calculated thruster force in pound-for-seconds. Imperial units. The system used in the United States for most everyday measurements. NASA's navigation software at JPL assumed the data was in Newton seconds. Metric units. The international standard used by every space agency on the planet. Nobody checked. Not Lockheed Martin. Not JPL. Not the systems engineering team whose entire job was to make sure everything connected properly. The difference between a pound force and a Newton is a factor of about 4.45. Small number. Massive consequence. Every single thruster correction for 10 months was off by a factor of 4.45. The spacecraft wasn't where anyone thought it was. It was drifting. Slowly. invisibly, inevitably. On September 23rd, instead of entering orbit at 226 kilometers above the Martian surface, the minimum safe altitude was 80 kilometers. The orbiter came in at somewhere between 57 and 110 kilometers. It hit the atmosphere. It burned. $125 million. 10 months. Gone. And now comes the part everyone gets wrong about this story. The easy answer. Lockheed Martin screwed up. They used the wrong units. Their fault. But that's not what NASA's investigation concluded. Yes, Lockheed Martin failed to convert to metric. That's where the error originated. But the investigation found something more uncomfortable. The systems engineering function, the team responsible for catching exactly this kind of mistake, wasn't robust enough. Communication between the two teams was too informal. The navigation team was understaffed and overloaded. Warning signs were raised and dismissed. And the faster, better, cheaper philosophy, which sounds great in a budget meeting, had quietly hollowed out the redundancies that would have caught the error. The investigation board's exact words. The problem here was not the error. It was the failure of NASA's systems engineering and the checks and balances in our processes to detect the error. One mistake. 10 months to grow. 0 systems to stop it. NASA changed after this. New protocols. Mandatory metric standards. Independent review teams. Better communication channels between contractors and mission teams. The Mars exploration rovers, Spirit and Opportunity, launched in 2003. Both succeeded. But here's what stays with me about this story. The error was known. Not the unit mismatch specifically, but the drift. The numbers that didn't quite add up. Someone noticed. Someone flagged it. Someone sent a memo. And nothing happened. Because the system wasn't built to listen. Small cause. Massive consequence. Not just a wrong number. A culture that made it impossible to catch the wrong number in time. $125 million. 10 months of travel. One assumption nobody checked. That's all it takes.